Good morning, ladies and gentlemen. I'm Claude Joyens. I'm in charge of the business side of ECOROBOTIX. So ECOROBOTIX is a Swiss-based company. We are placed in the French part. We exist roughly since 6 years. We employ today about 30 people, mainly engineers. And our purpose in life is to develop and manufacture high-precision weeding robots. So this morning I will present you from ECOROBOTIX perspective what we mean with advantages of high-precision weeding, or what we also call spot spraying. The first step is, of course, to define what we mean with high-precision weeding. So we need to discuss about those topics like recognition of the species, the footprint of the spray, so what we call the pixel, the spraying pixel, the accuracy, how we position it, and also the capacity to make jigsaw of those pixels, and of course still guarantee a high throughput of the robot. So let's start with the recognition of the species. So this is one of the most important steps, is the capacity of the robot or the intelligence to recognize the geometry of each plant. So really from the top to understand where each leaf's boundaries are. So once you have that map, and this is a high dynamic map, we need to refresh that several times per second. You need to recognize what is this plant. Of course, you need to recognize it for the crops. So you need to understand the species of the crop. But also it's interesting to recognize the species of the weeds. Because that will allow also to make to spray with different mixture depending on the family of the weeds. So once you have that map where you really understand where each plant is, okay, that's a sugar beet, that's an amaranth, that's a canopod. The next step is to spray and to spray as accurately as possible. So there is two aspects of it, is the spraying pixel size, and as we believe that the most interesting spraying time is in the early stage, you have to be able to spray a pixel that is as small as possible. So in the case of ECOROBOTIX, as you will see, our pixel at the moment is about 8 centimeter width on 2 centimeters long in the direction of the robot. So that's the first aspect. And then, of course, you need to be able to position that pixel with a high accuracy. So from the map here, you have to imagine that the camera is about 1 meter in front of the sprayer. So not only you need to recognize and understand where they are, but you have to have an absolute position of each plant, and then you have to calculate very accurately the movement of the robot to make sure that you spray on the right time. So that's the second aspect of it. Once you are able to put those stems that are the spraying spots, you have to be able to build complex shapes that will cover the weeds. So if it is a small weed, you may need only one stem, but if it is a big weed, then you need to be able to patch several pixels together. But you also have to be able to patch them around the leaves of the crops. And this is what I demonstrate on the lowest pattern. So you need to, at the same time, cover all the weeds, but not touching the leaves of the crops. And that's a kind of a challenge, because you have to do that with high speed. So at the moment, our robot is driving with about 1 meter per second, and we do 2 meter widths. So 1 meter per second is something like that. Meaning that you need a lot of calculation to be able to do a width of 2 meters at that speed. So now that I have defined roughly what we mean as high precision or spot spraying, what are the advantages? Of course, one is obvious, is that we are going to use much less chemical. How much is a pure question of geometry. So if you have only 10% of the field which is covered with weeds, then you spare 90% of the chemical. Another advantage is that we can spray not only in between the rows, but of course on the rows of the crop, of course provided there is enough distance between between the crops on the row. A very important parameter also is the fact that we allow for higher yields, particularly on the crops which are sensitive to phytotoxicity. So even if you have a selective herbicide, if you take plain field vegetables like onion, spinaches, string beans, of course they will survive to the selective chemical, but they will be hit and a little bit shuttled, so you lose yield during the season. We made a test with onion producer in the center of France, and we arrive easily with a gain of yield when you don't spray the crop of 2-3 tons of onion per hectare. So that translates into quite big money per hectare. So if you calculate that in terms of money, per hectare, the total cost of weeding per year on an onion field in the center of France is roughly 400 €. So they have to make about 4 or 5 passes in the season. To that, you add the loss of yield. It's roughly 200, 250. So you arrive close to 700 €. That's the total cost of the weeding, conventional. So that's with the tractor and the sprayer, plus all the chemical you need. So 400, 450 plus the 250 about of the crop yield, it's 700 total cost per year, per hectare. If you do that with our robot, we arrive to roughly 450. So another advantage of the spot spraying that I should have mentioned is this is a solution that is bringing also an economic advantage to the farmer. So we really made our utmost not to bring only a technology, but a tool that could be used by the farmers and that will provide them an economical benefits. We see also arriving an interesting application of the spot spraying outside of the pure weeding. It's when you need to apply a product with high accuracy, maybe not on the weeds, but on the plants. So there is maybe 2 examples. We are making tests and pilots with a company which is manufacturing an insecticide, so a biocontrol insecticide for the small, in English, les pucerons, so those small black things on the rapeseed that are eating the small rapeseed plants. And of course, when you have to apply the rapeseed plants, they are small, so the plants themselves, they represent a very small percentage of the total field. And with spot spraying, we can spray on the plant this time only, and we spare a lot of product. And those products are expensive. So we also, one advantage of spot spraying is that we believe that we will enable the usage of biocontrol or biologic products that would be much too expensive to be sprayed on the complete field. But when you spray only where you need it, then the economical side will be okay. So, yeah, Mommy's calling. The solution we are providing is of what I presented is summarized into our new baby. So we are very proud to be here because that's the world premiere of our new robot, AVO. Because in the past we had another one. You may have seen in the video the one with the delta arms. We had about 15 of those previous robots in the field over the last 2 years in various countries. We have learned a lot. We have also seen the limit of that robotic arm machinery. We were too slow in the throughput. So we decided to move the vision, what I explained, technology, onto a new platform, which is AVO. With this machine, we are able to achieve a throughput about 8 to 10 hectares per day. So we replaced the delta arms with a spraying boom, a spraying bar with a nozzle every 4 centimeters. That is allowing the 8 by 2 centimeter pixel with an accuracy of plus minus 1 or 2 centimeter. Basically, AVO stands for Avoset, which is a small hummingbird. So it's a species of hummingbirds. So it's a small bird which is very lightweight, very intelligent, which has a fantastic vision, and which is able to work very accurately with this tool, which is this back. So I'm arriving at the end of my presentation. So if you have a further question, I can answer a few questions now, or you can also come on to our booth later on. Do you have questions?
We have plenty of time for 1 or 2 questions. There.
Hello, Claude. It's Rowan Rainbow from Australia.
Ah, yeah. Hello again.
Yes. One of the market drivers for these types of systems in Australasia is reduced herbicide contact with the plant, with the aim of reducing chemical residue levels in the plant so we can improve market access for those products. Have you done studies with your system looking at the resulting chemical residue reduction in the crop?
Yes, well, we have made, the first step for us is to measure the percentage of plant we are touching, because when we are working very well, we don't touch the plant. So indeed, from the top, there is normally no residues. So what we have measured is that at this stage, with our technology, we are touching only 2% of the leaves of the crop. But at this stage, we haven't tested what is the toxicity of those 2% means for a particular crops. That needs to be still tested. But of course, our aim is to reduce as much as possible the percentage of the leaves which are touched. It's not easy because there is a point, when you have a weed which is really touching the crop, very often we have a bit of product to go also a little bit on the leaves of the plant. So I think 1 or 2% will be the limit of what we can achieve. Or we can also, per software, give a boundary, a reserve, or we say to the machine, you don't go further than 2 centimeters from the outside boundary of the crop.
Maybe another questions here? Ah, sorry, there was another one there.
Hi, Jose Miguel from Hortifood Chile. What is the capacity of a spray tank, and how autonomous is the solution?
Yeah, that's a good point. We have roughly 140 liters. It's basically about 130 liter of pure water. And we have also 4 small tanks of pure chemical that can be mixed on the fly into a small reservoir together with the water. So we do the mixing on the fly, not to have too much mixing preparation in advance. And in terms of the autonomy, there is two parts. There is the energy and the navigation, and we are fully autonomous on both sides. So in terms of energy, the robot, from let's say April to September, with good illumination, is able to work autonomously thanks to his solar panel and onboard battery during easily 12 to 16 hours. So you don't need to go back several times per day on the field to exchange battery. But still, if you want to work during the night on the battery, the robot will work 3-4 hours, depending on the soil condition, just on battery. So it could work 24 hours. But then in the night, you have to exchange the batteries. And then in terms of the navigation, it's also fully autonomous. It's using a combination of vision detection and GPS RTK to navigate absolutely autonomously on the field.
Thanks. Last question. Quick questions, quick answer.
7 seconds.
Yeah, quick question about the resolution of your spraying. You were mentioning 8 by 2 centimeters, driven by the speed of your robot. You were referring to this machine, and where do you see the limit in terms of daily throughput?
Yeah, basically the size of the pixel is given by the type of nozzle we do find on the market. So at the moment, that's the best nozzle we have found. And we have that spraying pattern when the boom is at 15 centimeters high. Of course, if you go higher, then we have still a small angle, so the pattern will be bigger. Certainly in the future, we can reduce it, so we can narrow the angle. And this 8 by 2 is based on the 8 to 10 hectares per day.